Problem number 2 on 3.4. There's this weird thing they do where they ask which is different. So it's a little bit confusing, but follow along if you will. All right. So there's the distance from point X to line WZ. And this is point, so that's this right here. So in other words, this right here would be the length of XY. That's what they're talking about, because the distance from this point to that line is the shortest distance there, and that would clearly be that. So XZ is obviously different. This is a different length, right? It should be longer. This and this are the same, right? And the distance from L to point X, that's also, yeah, because line L is line WZ. WZ, see how W and Z are on there? Line WZ and line L is the same. So the only thing that's different here is XZ. This is the different one. So that's this answer. And then to find the two distances, so let me erase here a little bit so I can see what's going on here. So if I have them graphed, I'm really looking at, see how there's a right triangle here? The grid makes a nice right triangle. We're finding that, and we're finding this. Right, the two parts of the right triangle. This is 1, and this is 1, 2, 3, 4, 5, 6, 7. So XZ, the length of XZ is the square root of 1 squared plus 7 squared. That would be 1 plus 49 square root of 50. Use your calculator to get the this one would be, this is the different one. The same one, all of these were this length right here, and you'll notice that's 2, and this is 1, 2, 3, 4, 5, 6, 6. So XY, also known as the distance from L to point X, is 2 squared plus 6 squared and the square root of that. So that is 4 plus 36. That's square root of 40, which is some other number. Use a calculator.